Chapter 9.2, Direction Fields and Euler's Method. Unfortunately, it's impossible to solve most differential equations in the sense of obtaining an explicit formula for the solution. In this section, we show that despite the absence of an explicit solution, we can still learn a lot about the solution through the graphical approach, direction fields, or mathematical approach, Euler's method. See figure 1 on the sidebar, a solution of y prime equals x plus y. We have a slope at the coordinates x sub 1 and y sub 1 is x sub 1 plus y sub 1, and there's a slope at the coordinates x sub 2 and y sub 2 is x sub 2 plus y sub 2. To the text. Direction fields. Suppose we are asked to sketch the graph of the solution of the initial value problem y prime equals x minus x plus y. Y of 0 equals 1. We don't know a formula for the solution, so how can we possibly sketch the graph? Let's think about what the differential equation means. The equation y prime equals x plus y tells us that the slope at any point open x and y close on the graph open called the solution curve close is equal to the sum of the x and y coordinates of the point. See figure 1. In particular, because the curve passes through the point open 0 and 1 close, its slope there must be 0 plus 1 equals 1, so a small portion of the solution curve near the point open 0 and 1 close looks like a short line segment through open 0 and 1 close with slope 1. See figure 2. Sidebar, see figure 2, beginning of the solution curve through open 0, comma 1, close, coordinate to O1. Slope at O1 is 0 plus 1 equals 1. Back to the text. As a guide to sketching the rest of the curve, let's draw short line segments at a number of points open x and y close with slope x plus y. The result is called a direction field and is shown in figure 3. For instance, the line segment at the point open 1, x equals 1 and y equals 2 at the point open 1 and 2 has slope 1 plus 2 equals 3. The direction field allows us to visualize the general shape of these solution curves by indicating the direction in which the curves proceed at each point. See figure 3, direction field for y prime equals x plus y. See figure 4, the solution curve through the point 0, 1. A sidebar, module 9.2a shows direction fields and solution curves for a variety of differential equations. Back to the text. Now we can sketch the solution curve through the point 0, 1 by following the direction field as in figure 4. Notice that we have drawn the curve so that it is parallel to nearby line segments. In general, suppose we have a first order differential equation in the form y prime equals big F open x and y close, where big F of x and y is some expression in x and y. The differential equation says that the slope of a solution curve at a point x and y on the curve of big F of x and y. If we draw short line segments with slope big F open x and y close at several points, open x and y close, the result is called a direction field or slope field. These line segments indicate the direction in which a solution curve is heading, so the direction field helps us visualize the general shape of these curves. Example 1. Part A, sketch the direction field for the differential equation y prime equals x squared plus y squared minus 1. Part B, use part A to sketch the solution curve that passes through the origin. Solution. Part A. We start by computing the slope at several points in the following chart. We have different rows.